Good morning, everyone. My name is Peter Cook. I'm a member of the advisory board of the Boundary Dam project, and it's my pleasure to be today's facilitator. I'd like to get the morning off as soon as we can. We've got an ambitious agenda for the day, and I'd like to introduce our first panel on the topic of advancing technologies for tomorrow. Next generation CCS technologies are being planned, tested, implemented every day across the globe, and each presentation in this session will explore the research undertakings necessary to advance CCS. Please welcome to the panel the following members of the panel, and I'm not going to give extended CVs for people. They're there in your brochure, in your folder, and I'd refer you to that. On the panel, we have Frank Morton, Consulting Engineer, National Carbon Capture Center, the Southern Company. John Gibbons, Principal Investigator, UK Carbon Capture and Storage Consortium. Max Ball, Manager, Carbon Capture Test Facility, SaskPower. Olaf Falk Pedersen, Business Development Manager, the Test Center at Mongstad. And Peter Radkin, the head of E.ON's Innovation Center for Carbon Capture and Storage.
Good morning, ladies and gentlemen. I'm very happy to be here and give you some insights on where we are on CCS. And as you can see from the slide, I think CCS has a challenging program. We need to innovate, initiate, and develop. We need to improve, implement, and demonstrate. And I think SaskPower is clearly the project where we demonstrate CCS. Well, that will be not enough. A single project might not help us to save the world. So we need to finally industrialize, internationalize, so bring it to more countries than single countries to decarbonize the world. And I think that's the target why we are talking about CCS. We want to decarbonize our world. So let me, I would like to give you some overview on what we are doing in regards to driving CCS development forward. And for sure, when you're dealing with the technology, you have to work on the full value chain in R&D. So you need to look on basic research, you need to look on applied research, you need to do the pilot testing, as there are always some challenging when you're moving from the lab into the real environment, and you need to have the demonstration. And the challenge which is associated to it is, if you're doing basic research, typically you can do it at small scale, little number of people involved, so with acceptable cost, and as more you're moving to the right side to the demonstration, as more costly it gets. So what we are doing at E.ON is we're looking on a number of things. So we are doing more what is basic research, so we're looking on second and third generation technologies. For example, membrane separation. Membrane separation in principle is well known, but there are a number of challenges in regards to the energy demand, the efficiency of the separation, and so on. But there are new ideas coming on the horizon which you need to test. So we are working on this. We are looking also on things like carbonate, or sometimes called calcium looping technologies. So you're having a material, a solid bed, or two solid circularized fluidized bed, and you're running the process at very high temperatures. And what is the big advantage is if you have a post-combustion plant, typically the recovery of the CO2 takes place at something like 130 to 150 degrees centigrade, and the waste heat is about at 100 degrees, so you can't do anything with it. In this kind of process with the calcium looping, the waste heat is available at 500, 600 degrees, which means you can bring it back into the steam cycle, and therefore you can reduce the overall energy demand. What we have done as E.ON is we tested a broad variety of first generation post-combustion technologies. And you can see it from the left. We had a project together with TNO at our power plant in Maasvlakte, where we tested a long number of hours with MEA, with other solvents, and we learned a lot of lessons there on, for example, emissions. We also tested with other manufacturers, for example, with Siemens. We were testing at a power plant the amino acid salts. With Alstom, we tested at pilot scale the chilled ammonia process. And we are also running with Fluor together a test facility at our power plant Wilhelmshaven. And with this plan, we are also being partner in the International Test Center Network. When you're looking on these first generation technologies, for sure, we still need to reduce the cost in terms of CapEx and OpEx cost. So you need to look on where you might be able to have further improvements of the systems. And what we are, for example, doing is we are working on just replacing the currently used structured packing column, just like the desulfurization. We are trying to apply spray absorbers for CCS as well. And this has a number of advantages. It's getting your columns much cheaper, and you're reducing the pressure drop significantly, which saves you a lot of energy. And at least we are working on a large-scale demonstration project, even bigger than the Boundary Dam project. It's called the ROAD project, which stands for the Dutch acronym Rotterdam Opslag en Opvang Demonstratie project. It's a 250 megawatt slipstream of a 1,050 megawatt coal-fired power plant located in the harbor of Rotterdam. And it's a joint venture activity together with GDF. We have Tucker as a potential storage provider, and for sure we have financial support from the European Commission and the Dutch government. How does it look like? You see a slide on the slide, the power plant. It's a new build, a large-scale power plant, which is coming to starting operation, commercial operation, end of this year. And we have planned to have a CCS demonstration plant fitted in a slipstream of a quarter of the total flue gas. Despite what you typically do when you're starting a project, you're doing a lot of feed work, but we have done much more in this project. So we have really putting on hardware on this power plant. So what you can see here, we have implemented the flue gas tie-ins and the steam tie-ins so that we really would be able to retrofit the CCS facility easily into our power plant. So what are the challenges? We have run through the full engineering cycle. We have nearly completed the engineering. We have all the permits in place, which is sometimes challenging. It was the first storage permit ever granted in the European Union, which we received for the project, which got approval by the EU Commission. We have the contracts negotiated, but the big hurdle is the financing. And we are facing a significant challenge in Europe, trying to get projects to be economically. There is no business case for CCS in Europe, which hinders all movement in Europe to drive CCS forward. And what is the background? Why it's not economic? Well, we heard that EOR is one business driver for CCS. In Europe, we do not have EOR applications, so CO2 storage is only a cost. In addition, what we assumed is that when we started all these kind of project activities, and therefore I tell it like a fairy tale, once upon a time, there was the expectation that carbon prices in Europe, the key driver for economics of CCS project in Europe, will go up from 30 to something like 50, maybe more euros per ton of CO2, but the opposite has taken place. So the price has fallen to values of something like 5 euros per ton. If you store 1 million tons of CO2 per year, this means you're losing, just by this carbon price reduction, 25 million euros per year on operational profit. Well, you're reducing the loss, not making a profit. The second effect, what we have seen is that electricity prices are heavily under pressure. We do not see any electricity consumption increase in Europe. The consumption is going down, and we see increasing renewable production, which puts a pressure on the electricity price. It's the market, therefore supply and demand determines the price, and during the last 4 years, prices have fallen and fallen and fallen. So there is no appetite to invest at all in any power plant. So CCS, where we are, where we go. And I think what is the key question we have to answer? What is desirable for users? And I think everybody would agree we need to decarbonize. The second question we have to answer, what is possible with technology? And I think what is a very good achievement of Boundary Dam is that we can really demonstrate that the technology is working, it's efficiently, it brings down the CO2 emissions of a power plant, it can contribute to the reduction of CO2 emissions. But in Europe, we need to make it also viable in the marketplace, which is not the case yet. So we need financial incentives to make it happen. Widespread CCS development requires a global carbon price, and I think that is important that also Europe looks on the competitiveness of the industry. So it's a global challenge which needs to have a global answer, and therefore I think we are all looking forward also for the climate change negotiation next year in Paris. And I would like to close with a very known, famous German writer, Johann Wolfgang von Goethe, who have written, "It is not enough to know, it has to be applied. It is not enough to intend, it has to be done." Thank you.
Thank you for that, Peter. Our next speaker is Olaf Volk-Petersen, and he's talking about the test center Mongstad experience, the planned and the unforeseen.
Yeah. First of all, thank you for the opportunity to come here today and talk a little bit about what we are doing at TCM, and also really delighted to be here during the opening of this full-scale plant. This is really, I think, great for the CC activities. TCM is, as most of you know, a large test center in Norway, where we have at present 2 capture units, test units. We have a available area, we have a very flexible utility system, and we have access to 2 exhaust gas sources. One of the main plants is the amine plant. We have a large-scale test facility, and this large-scale amine plant has been used for tests first with Aker. We have tested 2 different solvents, which has been developed by Aker. And we are really happy to say that these tests have been very successful. And Aker is now commercializing these technologies into the market, especially against the market in the US on the EOR. We also performed, and this is very important, a extensive MEA test campaign with exhaust gas from the CHP, the gas-fired power plant. We have focused on emissions, on energy consumption and design, process optimizations, limitations. We think this is really important that for the whole community that we can have a good baseline. What is the actual consumption? What is the actual cost involved with CCS? And all these results will be published in detail next week during the conference in Austin. What we are working on with TCM now is to prepare for the startup of a test campaign using the shell cancel process. We are more or less ready to start, and that will happen within a short period of time. We will then go into a test phase where we will focus on the performance and energy, for instance, and emissions and process verifications in general. This test will be done in 2014, of course, and into 2015. If you look into the unit itself, it's a large-scale laboratory. We have approximately 4,000 online measuring points at site, and we are focusing a lot on getting a good mass and energy balance. This is the system which is installed at the top of the absorber to get the CO2 balance as good as possible. One of the benefits with TCM is we are running with a plant, the gas-fired power plant, which is a baseload plant, so it's very, very stable. So we can run with this system, get good results, even if the system is going in a loop. which means that we are not getting the results every second, but we need a stable process because we are taking for one period of time from the exhaust gas coming in, another time from the exhaust gas going out, another time from the CO2 produced. This is working fine as long as we are stable. But what we see now, and we find more and more important, is the fact that we are entering into an area where the power plants are used more for peak shaving, and we are much more into a transient system. And what is the key for us is to understand how shall we operate a amine plant in a very dynamic process. So to be able to measure this, what you see here on the lower part is the results from a test we did, showing that an amine plant can be up running in roughly 2 hours. But we would really like to know what is the really performance. So we have now close to finalize the major modification project, where we have installed a really large amount of new instruments, and also with new sample lines, which means that we have now analyzed this online, real-time from the main sources. This will give us two things, which is an even higher mass and energy balance. At the same time, it will also give us the possibility to study the processes in the transient operation, which we find very important. But regardless, instruments, laboratory is definitely very important. And we have a very good lab, which is handling more than 100 samples a day when we are in full operation. At TCM, we run roughly 1 test a day. But with this new system, we can also make the tests even more efficient by having this new instrumentation. So then we know fairly well what's going on because we have good instrumentation. So we can compare it with models. Sometimes when you compare it to models, you find that you have some limitation in your process. What you see here is pictures of our strippers. This is industrial size strippers. And what we have seen, and which we are also presenting in Austin, is that we had a bottleneck in the stripper due to the distribution and of steam into the stripper. So it's very important not just to measure correctly, but to understand every process component and to make them optimized. So this is something we will continue to work with, because what we are doing now is that we are looking into the future activities at ECM. And what we would like to do is to test, of course, mature technologies with limited modifications, but we would also like to go into more novel solvents and processes. And we think it's to be able to really test new solvents, novel solvents, we really need to understand the amine process in basic. That is why we are doing the investments we are doing at present, to be prepared to be a good test center for novel solvents, so we can get high quality and good results as fast as possible. Another thing which is important is that an amine plant, for instance, consists of a large number of components. And we are also very interested in testing out different process components. It can be demisters, packings, heat exchangers, all kind of instrumentation to make sure that we have a totally optimized process, which can also handle the transients. So TCM is at present in a close dialogue with possible users, technology owners, and I think what will be important in the future is that we will get closer into dialogue with the end users. Because it's the end users like SaskPower which have the problem if it's not really working. And TCM is a very good place to do troubleshooting and also to do training of operators and to make sure that the process will work as it should. And of course, we are interested in a continuous dialogue with possible users. The CAP unit, we also have a big chill ammonia plant. We have been testing now together with Alstom for since 2012, late 2012. We have tested it for 2 exhaust gas sources. We have had lots of troubleshooting, we have done modifications, and we have solved issue by issue in a very good dialogue with Alstom. And we're very happy that Alstom is now going to the market and selling this chilled ammonia process, especially against the EOR market in the US. This is something I got from Alstom, showing the roadmap for the chilled ammonia. I mean, they started their work in 2005, I think, in the university. Then a big company like Alstom came into the process. They got with them funding, they got with them other industry partners, and they have been doing a very fast track development. But to develop these types of technologies, it takes time. But I think what is good now is that since 2006 until today, a number of test centers has been developed and are in operation, like NCCC in the US, like what we have here with SaskPower and the TCM in Norway, for instance. So now we have the infrastructure in place, which can possibly cut down on the development time. At TCM, we have a big utility area. What you see here is the module where we are adjusting the temperatures of the exhaust gases. And we also have a available area. And this available area is a place where we would like to test out the skid-based units. So far, we have been doing studies with some technology owners, looked into the possibility tie-ins for how we can do it. How can we get the needed flexibility with our 2 exhaust gas sources and all the utilities? But what is also important is that we have already an available parking space for a module. This is the place where we had installed the mobile test unit from Aker, which also have been tested out at NCCC. So we have an available test space where we can install units. Our job at TCM is to reduce cost, technically, environmentally, and financial risks by implementing full-scale CO2 capture units. So what we have been doing is that we have 2 RFIs out. So we are in dialogue with people that are interested in the aiming plant and the available site. I think we have a very important test center network where also SaskPower is a partner. TCM owners, which is Statoil, Shell, and Sasol and Gassnova, also have a very good network within the CCS activities. We're also been doing technology survey. Sintef did a tremendously good job and made a report, which is available at the TCM's homepage, where we study different technologies. And TCM is also moving into the utilization. In Norway, fish farming is a big industry. The second after oil and gas is fish farming. And we are now looking into, and we will install a pilot plant where we will grow algae based on the use of CO2 and light. So TCM is there. We have been doing some good tests. We are very happy that the companies we have been tested for is happy with the work and that they are go commercial with the technologies. We are very happy that we will start up the new test now with Shell Cancel. We're sure that will be successful. We are modifying the plant to be ready for the challenges which we know will come, and we are still open for dialogue with possible users. So thank you.